Hello everyone, I'm Sagie from Huawei European Research Center. With me presenting today is Liran Schour from IBM Research Center. We are going to present to you a concept we call topology service injection. What this means in a nutshell is we want to allow external applications to inject their logic in OVN pipeline and do it in a secure way. And we'll explain more as we go in this presentation. Before I will start explaining what is topology service injection, I want to do a brief introduction to classic service chaining. This is an area that was well covered yesterday, so I will not dwell too much on it. The point I was trying to make in this slide is that we usually have the virtualized network function. We have our network infrastructure. In OVN case, it's the OVS pipeline. And to this infrastructure, these functions are just like any other ports in our system. And it doesn't matter if we are using NSH or any kind of headers to transfer information to the infrastructure or use some sort of API to define this chain. The infrastructure is still in charge of forwarding traffic to and from these functions. In a classic service chaining, we'll usually have a classifier that classifies traffic to enter to a certain chain. And then we have two types of chain. We have static chains, which means every packet that enters the chain will go through all the functions in it and the same packet after it. And we have dynamic chains, which essentially means that the function itself has a way to signal the infrastructure or the next function in the chain some information. And we are able to do some flexible stuff with it, like change chains in the middle or do all sorts of forwarding decision. There are some common headers to do this, like NSH, which was presented yesterday, more standard protocols like MPLS and application ports. The endpoints, the functions themselves are usually VMs or containers in the standard case, but it could also be user space application or physical ports using the VTEP scheme, Layer 2 gateway, or provider networks in OpenStack. So this was a brief introduction to service chaining. What is topology service injection? In topology service injection, we want to allow external application to interact with our networking infrastructure, basically installing their logic inside the forwarding pipeline. The API to do that will be an OpenFlow-like or OpenFlow exactly, but it's important to note that we want this process to be secure. We don't want any application to interfere with all the traffic that is passing in the pipeline. In order to accommodate these requirements and the way that we envision this feature being done is a user or external application register itself to the network infrastructure and then attach the service to one or group of logical elements in our environment. So in OVN case, we have the logical ports, basically the VMs or containers, connected to logical switches, connected to logical routers. And the service can attach itself to any one or group of these elements. What this provides us, it's basically allow the feature of topology injection to be a service feature, because now a tenant could have its own application, its own services, and he will only be able to attach these services to logical elements that he owns in the system. What this means that only traffic that traverses these elements will reach the external application parts in our pipeline. And this also allows a very flexible environment to admin that wants to set specific services on specific elements. It's important to note that the network infrastructure, in this case, will be in charge of compiling the final pipeline based on the default base pipeline and on the attached services. When you come to think about topology service injection, it's very similar to NetFilter or IP tables, if anyone's familiar, where we have these predefined hooks, post-route, pre-route, forwarding, and so on, and the user is able to insert their own filtering rules in these places. We are allowing to extend the OpenFlow pipeline, the base pipeline. And I think the most important point in this feature is that we are allowing to extend OVN without actually changing or inserting code in OVN itself. So I described to you classic service chaining, topology service injection. What I want to show now is how these two work very well together and how they complement each other. We have here a simple example where we have an IPS function and a group of VMs. Traffic is chained to go through this IPS, and it's inspecting them. And it suddenly recognized that one of the VMs, VM1 in our example, is infected with a Trojan horse or a malware, and it wants to block its traffic. With classic service chaining, what we would do is block the traffic in the IPS itself. With topology service injection, we could have a designated place in the pipeline that is owned by this application, and it could already install quarantine flows in this place and block the traffic on the infrastructure. What this allows us, it reduces the load on the function itself. This is, of course, a simple use case. There are other use cases. For example, if this IPS was an IDS and wasn't on the data path but got mirrored or tapped traffic, then topology service injection is the only way it could block the traffic. We could think about a DPI function that does quality of service and then install marking flows in the infrastructure. And we can think about also load balancer, distributed load balancer function. We want to do applicative load balancer that get the first packets of the connection and then wire the connection from a client to a specific server. And there are many, many more ideas of how to combine these two together. And I hope I showed you that these two concepts complement each other. So what I showed you is service chaining, topology service injection, and how they combine together. Liran will now show you how we suggest to implement this in an abstract way in OVN, another use case, and a demo of this.
Do you hear me? Yes? Yes. OK. So what do we have today in OVN? Today we have a fixed logical pipeline in OVN. So the cloud management system, in OpenStack case, it's the Neutron, defines the network topology. It creates logical switches and logical ports, logical routers. Then the NOVD will translate this topology into a logical pipeline inside the southbound DB. And from there, it will be compiled down to the vSwitches through OVN-controllers to a physical flow tables on the vSwitches themselves. So if we want to introduce new functionality to OVN right now, new service functions, we have to integrate our code into the OVN code base itself. So we are proposing a different way to do that by a service injection, by extending the OVN logical pipeline. So we have on the left the external service, and it defines with a new API of a northbound DB. It defines a new service and attaches it to one of the logical topology elements, router, switch, or logical port. And then it get back some kind of a token for future access to this new dedicated table that was created for it in the logical pipeline. Then it will add new logical flows to this new dedicated table into the northbound DB. And from there, NOVD will translate this new topology with the new service to a new logical pipeline with new stages inside the pipeline. And from there, usually OVN controllers will compile this logical pipeline into a physical flow table on the vSwitches themselves. then traffic will be based according to the new flow table. So we needed such a functionality in two European projects that we are involved in. One of them is Cosine, called Cosine. It is we have a hybrid infrastructure, electronic and optical infrastructure. And the other project is called Beacon, where we have data center interconnect with differentiated capacities. And we wanted basically to separate different flows on different fabric to route the elephant flows on top of the optical circuits in case of cosine. So what we actually did is we had a sflow collector that collect samples of the flows and detect elephant flows. Then via the OVN-enabled service marked these flows by a IP DSCP specific value. And from there, the fabric knows to distinguish these elephant flows and to route them over the optical fabric. So I will demonstrate a live demo. In the demo here, we have two hosts, host 1 and host 2. On top of them, we have two guests, guest 1 and guest 2, that will transfer files to generate traffics. In the middle, we have the sflow collector with an elephant detection. And above, we have the OVN southbound DB with the logical pipeline. So first of all, the sflow collector will start to collect sflow samples. Then it will detect a new elephant flow. It is a logical traffic between two guests. It will detect this elephant flow and then will write it to a dedicated table in the logical pipeline. I did here a little bit of a shortcut because I didn't implement the new northbound API to create this dedicated table. I just used a table in the pipeline that wasn't being used before. So from there, the OVN controllers will push this logical flow into physical flows inside the flow tables on the vSwitches, and then new traffic that will arrive will be applied by this new flow, and elephant flows will be marked with this specific DSCP fields. So now let's move to the demo. We have here in the bottom left, we will capture traffic on the wire, and we will look for packets with IP DSCP field equals to 64. In the bottom right, we will dump the logical pipeline flow table and the flow tables from the vSwitch itself to see if there are any new flows. In the upper left, this is the sflow collector that will detect elephant flows. And in the upper right, this is guest number 2 that will transfer files to guest 1 to generate the traffic. So first of all, I will start the sflow collector. OK. And then run the TCP dump to capture DSCP value equal to 64. And we'll start to copy mice files from guest 2 to generate traffic. You can see that I'm transferring mice files. There is no capturing of packets in the TCP dump because it's small files, small traffic. And if we look on the logical pipeline, we can see there are no new flows. So let's now stop this transferring of files and start transfer elephant file. So I will start to transfer an elephant file from guest 2 to guest 1. And you can see here the sflow detects the elephant flow, write it down to the southbound DB. And you can see here on the bottom left, there is the traffic of the elephant flow marked with the DSCP value equal to 64. So now let's see here the new logical flow. We dump the southbound DB and grep DSCP equals to 64. You can see here is the new flow with the action set DSCP to 64. And this is the matching rule of the flow. And if we look on the physical flow table of the vSwitch, we can see here a new flow with an action of modify network TOS to 64, and this is the matching rule of this new flow. So this is the demo. And to summarize what we just shown, we shown the value of adding new functionality by extending the logical pipeline of OVN without introducing new code, integrating new code inside the OVN. It was a quick proof of concept. We just marked elephant flows by DSCP field. And the goal of this discussion is to offer that, to include that in OVN, to try to generalize this case and to define a clean API that will be correct and secure and will allow us to introduce new functionality to OVN without integrating new code to OVN itself. So this is it. If you have any question.
Let's thank our speakers. So we have some time for questions. If you have a question, please come up to one of the microphones.
Hi. How would you enforce multi-tenancy security? So,
I can. It depends. The security part is where you. It depends how you define the API for the application to configure the flows, how it communicates, and how it installs its logic in the pipeline. So the simple case would be a token-based, but again, it depends on the API.
No, that's not. So because you're on the pipeline, so potentially you can see all the packets from all tenants flying within the pipeline. So do you have, you
Yes.
plan to have a kind of compiler, like a BPF compiler, to make sure that you have no way to snoop what's going on others?
Yes, so the way that, and I described it in the presentation, the way we see it is an API, for example, if you want to secure a tenant, so your tenant will only be able to attach these places in the pipeline to the logical elements that the tenant owns. So he won't be able to actually change all the pipeline, all the places in the pipeline that he wants, only the places that he owns. And for example, in OVN Node D, or any part of the network infrastructure will need to enforce that he won't be able to install.
The new API will not show the whole pipeline to the tenant.
Yeah.
Only specific parts, and will be able to allow specific actions on each part of the logical pipeline.
A question about the sort of performance. If you're pushing rules into the controller, how quickly do they propagate into the actual pipeline? And when you're doing these kind of dynamic traffic shaping use cases, don't you create a lot of churn, which would then stress the scalability of the OVN controller?
It is a matter of how frequent you'll do that. If you have many changes of logical flows, it won't scale. But here, once you identify an elephant flow, it will stay like that.
Yeah, I'm imagining, suppose you're using it in like a Hadoop cluster, and you have tens of thousands of elephant flows, and they're churning. It wouldn't necessarily be applicable to that kind of use case.
If I can answer that, we showed here a concept and an implementation. Okay, in a concept way, you could say how a centralized controller can work and install flows. It's essentially the same concept. We are allowing an API for external application to install their flows in what is a basic static pipeline. Okay? Implementation-wise, of course, we could think about ways to improve performance, do it in a better way.
Well, I guess your out-of-band controller could talk directly to the Open vSwitch instances and talk to that table.
So that's one option that it could be implemented. There are many other options.
And have you also thought about pushing MPLS tags as a control action?
Yeah, that's cool. The way I see it is that I think both of us is any action that you could have in OpenFlow today, you could use this to implement.
Okay. Great demo. Thank you.
So I have my question is more about the compilation that you are doing. How complex is the compilation to develop the service chain? And when you inject a foreign topology, and if your compiler does not accept it, what happens? Because you talked about IPS, and there are so many things which are quite complex, and if they have to be done in real time, is your compiler powerful enough to do things in the real time and ensure that the topology it is proposing is correct?
Yeah, so there is a difference between the compiler, which is compiling the pipeline. You attach a service, you attach it to several logical elements, and then the compiler, the OVN-NORD or any other infrastructure, needs to create the correct pipeline. But after it created it on the data path, the application now has an API to install flows in the designated place. So it's not recompiling things. It has its own, you could think about it, its own table in the pipeline where it can install its flows in it. So it's not something that is recompiling every time.
So I'm new to this. Maybe the question is dumb. How can we talked about connection tracking? Why can't the connection tracking be used to achieve this?
It can be used.
Okay.
We just picked to do that with sflow in this example.
All right, let's thank our speakers one more time.